I will very do a very quick review related with vector space. The proposition of vector space, what is important. If vector space V has a basis B, which is B1 to Bn, then any set in V containing more than n vectors must be linearly independent. Uh, and also, if a vector space V has a basis of n vectors, then every vector of V must consist of exactly n vector. And for dimension of vector space, you might confuse, so it is very important. If each row has n entries, then it lies in Rn. But the dimension of the vector space will be determined by how many of linear independent vectors, how many number of linearly independent vectors it has. And if it is spanned by a finite set, we will call it finite dimensional. And if the dimension the zero vector space, zero is defined to be zero. That is very important. And when we calculate null space of dimension of null space of A and column space of A, we usually do make it row echelon form first. Then number of free value of variable is null space of A. And number of pivot variable is dimension of column A. And if you sum up together, then we can make number of column space, which is very important thing. And when you finding basis of column space and null space, and null space is indirect, so you usually just find basis and you can sum up. You can write it as format. You can write it as format of parametric equation. And for eigenvalue, when you find your eigenvalue, there will be also geometric interpretation will be also important. But the important thing is you can do a diagonalization. When you diagonalize, first, if there are distinct eigenvalues, then you can say it is linearly independent. In reverse situation, we don't know what will happen. And there's characteristic equation, which is scalar equation. And you can there's also related with determinant. Uh, when you find your determinant, you can use determinant property. And we will call matrix is similar if there is invertible matrix P, such as P minus 1 A P equals to B, or A equals to P B P minus 1, which is we just change the matrix. When we diagonalize we do PDP minus 1, but we change it to similar one, which is invertible matrix. If they have same characteristic polynomial, so if they have same eigenvalue, then matrix A and B are similar. This is very important concept. When you do diagonalize, you should find eigenvalue and corresponding eigenvector or eigenspace. Then you can find you can get P, and you can easily determine B. Then after that, you can do it PDP